Hi, 8th graders. We're going to do a quick review today on solving one-step equations. This is something you've learned in previous years that our book does not cover because it's an expected skill. But we're going to review it just for one quick day to make sure we are confident in our solving ability before moving on to more complex equations later this week. So this is our review of solving one-step equations. You should be following along with me and filling in your notes as I go. One of our first vocab words to think about is inverse operations. An inverse operation can be thought of the opposite operation that will undo another. Okay, so when we're solving, we need to make sure we use these inverse operations that undo what we see in a given equation. For example, addition and subtraction are inverse operations of each other because they undo one another, as well as multiplication and division. We saw this even last chapter in chapter 1, where squaring something and square rooting something were inverse operations. The other vocab word we're going to focus on is isolate. We're going to be told to isolate a variable a lot. How you isolate is by using the inverse operation to get the variable alone, right? If you feel isolated, you might feel alone. So that's what isolated means in this case, is getting our variable alone. So now let's work through some step-by-step examples. So here we are with 4 steps. Our first equation we're going to look at is x plus 2 is equal to 7. Some people like to draw an upside down T with a vertical line going from the equal sign. What that does is make sure that you do what you do on one side of the equal sign, you do on the other, because that's very important to keep your equation balanced. Okay? Next, you'll use the inverse operation. We see in this equation that our variable x is being added by 2. So we need to think, what undoes addition? Subtraction. Take important note that our example is showing us that we subtract 2 on both sides of the equal sign. And that's make sure we keep it balanced. 2 minus 2 is 0, so that cancels out. That's the whole point. Now we've isolated that x and gotten it alone, and then we just do what's happening on the right side here. 7 minus 2 is 5. So our final answer is that x is equal to 5. We can check that solution by substituting 5 in for our variable. 5 plus 2 should equal 7, and it does. So let's take a look at these 4 examples on the bottom. Oops, that's too big. Okay. The first one is a plus 8 is equal to 20. Some people like to box up their variable to bring it to their attention. I'm also going to draw this vertical line down the equal sign to remind me to do something on both sides to keep it balanced. I see that my operation is adding by 8, so I need to use the inverse operation. I know the inverse of addition is subtraction, so I'm going to choose to subtract by 8. Whatever number is messing with my variable, that's what I'm subtracting by on both sides. Make sure that you should have the exact same number on both sides of that vertical line. So there's nothing underneath that A. It falls down right to the bottom. Nothing's happening to it. 8 minus 8 is 0, so that cancels out. And then 20 minus 8 is 12. So there's our final answer. A is equal to 12. We can test that if we want. Checking our answer. Is 12 plus 8 20? Well, I know 12 plus 8 does add up to 20, so that's true. I'm checked. Let's look at the next one. My variable is m. I'm going to draw my vertical line down the equal sign. I see that m is being subtracted by 9. What is the inverse of subtraction? Addition. So I'm choosing to add 9 on both sides of that equal sign. There's nothing underneath m. It falls on down through the hole. Negative 9 plus positive 9 cancels out to 0. And then on the right side of my equal sign, 9 plus 5 is 14. Carry the 1. 24. So my final answer is m is equal to 24. I've solved for my variable. I can check that by plugging in or substituting 24 in for m. And 24 minus 9 is in fact 15. So I'm good to go. 2 more. The next one has our variable m right next to the number 3. We need to remember that when two things are next to each other in algebra, that means multiply. So what undoes multiplication? What's the inverse? Division. We're going to show division in this case by using the fraction bar. Divide by 3 on this side, divide by 3 on this side. We know that 3 divided by 3 is 1, so I'm looking at just 1m, that's the goal. And 12 divided by 3 is 4. So m is equal to 4. If I were to check this answer, I'd have 3 times 4, checking to make sure that it equals 12, and it does. So my answer is correct, that m is equal to 4. The last one over here is x divided by 4 is equal to 16. I want us to rewrite this how we normally see it. In algebra, you'd normally see this way because we know that the fraction bar means divide. We're kind of getting away from using this division symbol anymore. So when we see that the fraction bar is there, we see division. We know that the inverse of division is multiplication. So this is the only operation that does not go underneath. It's going to go next to your problem. So times 4 times 4. I know that multiplying and dividing cancel each other out, so I'm left with just an x on this side. I need to do 16 times 4 on the other side. Well, 4 times 6 is 24. Carry the 2. 4 times 1 is 4, plus 2 more is 6, so I get 64. If I check that answer, 64 divided by 4 is 16, and that's true. I'm good to go. So you have 4 examples of how to solve one-step equations. And it doesn't matter if the equations are backwards either. You can still treat them the same way, whether the variable's on the right side or the left side. Now you'll have some practice.